In this video, I'll explain what are partial derivatives and how to find partial derivatives of given function. So if you have y equal to f of x, then this is called as single valued function because there is one input x and one output y. So if you have the function z equal to f of x comma y, then this is called as two variable function. Here there are two independent variables x and y and one dependent variable z. Similarly, if you have w equal to f of x comma y comma z, then this is three variable function where there are three independent variables and one dependent variable w. So all these functions will come under multi-variable functions because there are more than one independent variable. If there is more than one independent variable in any given function, then the concept of partial derivatives comes into existence. So partial derivative of any function is nothing but the derivative of that function with respect to one independent variable by keeping all other independent variables constant. So, for example, if you consider this two variable function, there are two independent variables x and y. If you want to find out the derivative of this function, then you have to find the derivative of f with respect to x, and then you have to find the derivative of f with respect to y. Then we call these as partial derivatives. This also can be represented as dou f by dou x, and this is dou f by dou y. This symbol is for partial derivatives. We call it as dou. Dou f by dou x meaning is partial derivative of f with respect to x. So while differentiating f with respect to x partially, you have to keep y as constant. Then similarly, this is partial derivative of f with respect to y. When you are differentiating f with respect to y partially, keep x as constant. The same thing can also be represented as zx and zy because the function is z here, and these are called as first partial derivatives of the given function. First partial derivatives of z. That is because you can find the second, third, and nth order partial derivative as well for the given function f. So this is differentiating f with respect to x once. If you differentiate dou f by dou x with respect to x once again, then we call it as second partial derivative of z. The second partial derivative of z is denoted as, I'll write here, fxx, and second partial derivative of f with respect to y is denoted as fyy, or else dou square f by dou x square, dou square f by dou y square, or else this can also be written as zxx and zyy. Similarly, you can have second order partial derivative of z with respect to x y. The meaning of this is first differentiating the given dependent variable z with respect to x, then differentiating zx with respect to y partially, or else you can have zyx. So in this case, partially differentiating z with respect to y first, then partially differentiating zy with respect to x. So mathematically, dou f by dou x is written as limit delta x tends to 0 f of x plus delta x comma y minus f of x comma y divided by delta x. This is called as dou f by dou x. This is mathematical definition of the partial derivative of f with respect to x using the concept of limit. Similarly, dou f by dou y equal to limit delta y tends to 0 f of x plus f of x comma y plus delta y comma minus f of x comma y divided by delta y. You can use canonical delta as well, that is f of this delta also x plus delta x. This is also fine. So if it is second derivative, then dou square f by dou x square is limit as delta x tends to 0 fx of x plus delta x comma y, right here, comma y minus fx of x comma y divided by delta x. Similarly, you can write dou square f by dou y square as limit delta y tends to 0 fy of x comma y plus delta y minus fy of x comma y divided by delta y. That is how to define the second partial derivatives of the given function. Now, if you want dou square f by dou x into dou y, so in that case, this is equal to limit as first we have to differentiate partially with respect to x, then it is with respect to y. So, delta y tends to 0 fx of x comma y plus delta y minus fx of x comma y divided by delta y. Similarly, if it is dou square f by dou y into dou x, so in that case it is limit delta x tends to 0 because first differentiate f with respect to y partially, then with respect to x. So fx, so fy of x plus delta x comma y minus fy of x comma y divided by delta x. So this is how we define the partial derivatives mathematically. Let us take some examples to learn how to find the partial derivatives of given function. Find the first order partial derivatives of these two functions. These are two variable functions. So I will name the first function as z equal to 3x square plus 4xy minus 5y square. You can name that as f also. Now z is the dependent variable, x and y are two independent variables. So first to find the partial derivative of z with respect to x. So it is denoted as zx, which is equal to dou z by dou x. So you can write like this also. Now when you are differentiating z with respect to x partially, y is taken as constant. So take the first term 3 into derivative of x square with respect to x is 2x plus 4 is a constant, then y is taken as constant. Now find derivative of x with respect to x, that is 1, minus 5 is a constant, y square is also constant, so derivative of a constant is 0. So we'll get zx equal to 3 to the 6x plus 4y. This is first partial derivative of z with respect to x. Similarly, find out first partial derivative of z with respect to y, which is dou z by dou y. Here, you have to keep x as a constant. Now, see, 3 is a constant, x square is also constant, so derivative constant is 0. So, 4 is a constant, x is also a constant, derivative of y with respect to y is 1, minus 5 is a constant, derivative of y square with respect to y is 2y. So we will get finally 4x minus 10y. This is the first partial derivative of z with respect to y. Now similarly, second one, you have to find out the first partial derivatives of this function z equal to log of x square plus y square. So it is zx first partial derivative, keep y constant. So log of any value, derivative of log of x is 1 by x. So it is 1 by x square plus y square. The chain rule rest all will remain same as you do for one variable function. The only difference is while differentiating with respect to x partially, keep y as a constant. So derivative of a log of any value 1 by that value into now x square plus y square. So x square derivative is 2x plus y square is taken as a constant, so it is 0. Hence you will get it is 2x divided by x square plus y square. First partial derivative of z with respect to x. Similarly, first partial derivative of z with respect to y, derivative of log of any function is 1 by that function, then chain rule, derivative of x square plus y square, it is partially with respect to y. So treat x as a constant. So x to the power any value, still it is a constant. 0 plus y square derivative is 2 into y. So that gives you 2y divided by x square plus y square. This is how we calculate the first partial derivatives of the given function, which is of two variable function. Now here is a second problem. If u equal to log of root of x square plus y square plus z square, then you have to show that dou square u by dou x square plus dou square u by dou y square plus dou square u by dou z square equal to 1 by x square plus y square plus z square. See the given function, it is a function of three variables. That means there are three independent variables x, y, z and one dependent variable u. And here they are asking second partial derivative of given function u with respect to x, y, z respectively. So I will find out first dou u by dou x. Dou u by dou x is equal to differentiating u with respect to x partially. When you are differentiating the given function with respect to x partially, keep y and z as constant. So what is derivative of log of any function? 1 by that function. 1 by square root of x square plus y square plus z square into, then chain rule, root of any function. What is derivative of root of any function? 1 by 2 root that function. So 1 by 2 root x square plus y square plus z square. Then the derivative of x square plus y square plus z square, it is partially with respect to x. So y square z square taken as constant. What is derivative of x square with respect to x? Which is 2x. Then derivative of y square is 0, derivative of z square with respect to x is 0 because they are treated as constant. So we will get dou u by dou x equal to 2 cancels. So x divided by square root of this value whole square it is. So we'll get x square plus y square plus z square because square root and square cancels. So this is dou u by dou x. Now I want dou square u by dou x square. The second partial derivative is asked. That is equal to, you have to differentiate this function with respect to x partially now. So for that you have to apply the quotient rule. See here. The quotient rule is u by v whole dash is equal to vu dash minus uv dash divided by v square. So denominator here x square plus y square plus z square into derivative of numerator with respect to x, it is 1 minus numerator x into derivative of the denominator y and z are kept constant. Just you have to differentiate x with respect to x partially, that is x square. Derivative of x square is 2x whole divided by square of the denominator x square plus y square plus z square whole square. So simplify this, you will get x square plus y square plus z square minus 2x square. So x square minus 2x square gives you minus x square plus y square plus z square divided by x square plus y square plus z square whole square. Now similarly you have to find out dou u by dou y and then dou square u by dou y square. So that will be followed in the same way. So I'll write directly dou square u by dou y square can be x square minus y square plus z square divided by x square plus y square plus z square whole square. You can check with this. I'll not do it again. It is in the same way. First to find dou u by dou y. Everything same here. Instead of 2x you have 2y. 2 cancels. Then you will get y by x square plus y square plus z square. Then again quotient rule. You will get negative for y instead of x. Similarly dou square u by dou z square equal to x square plus y square minus z square divided by x square plus y square plus z square whole square. This is your dou square u by dou x square. Now they are asking the sum of these three. So sum of these three, can you get the term in the RHS? That I have to check. So add all the three. So I'll get dou square u by dou x square plus dou square u by dou y square plus dou square u by dou z square, which is equal to So add denominator is same. So x square plus y square plus z square whole square. Numerator first term minus x square plus y square plus z square. Second term is this x square minus y square plus z square. Plus third term is x square plus y square minus z square. So in this case, if one of the z square cancels, one of the y square cancels, one of the x square cancels, then you will get y square plus z square plus x square. So that cancels with that of the denominator, one of the value in the denominator. So you will get 1 by x square plus y square plus z square. This is what the required RHS. So hence we proved the required RHS, that is by finding the second partial derivative of the given function u with respect to x, y and z, then adding all the three. See the third problem. If u equal to e power x into x cos y minus y sin y, then verify that dou square u by dou x into dou y equal to dou square u by dou y into dou x. This is the given function, which is a function of two variables x and y. So first you have to differentiate u with respect to x partially, then ux with respect to y partially. So let us find out dou u by dou x first. Dou u by dou x equal to, you are differentiating the function with respect to x partially, keep y as a constant. So cos y is a constant here. Then you are remained with e power x into x. For that you have to apply the product rule. So e power x into x. So first function, what is derivative of e power x? E power x plus second function is e power x into derivative of x is 1. That is done. Minus here y is constant, sin y is also constant. No product rule here. Just you have to find out derivative of e power x, which is e power x. So after simplifying, you will get this x e power x cos y plus e power x cos y minus e power x y into sin y. This is the first partial derivative of u with respect to x. Then I have to find out dou square u by dou x into dou y. I have to differentiate this expression partially with respect to y now. When you are differentiating partially with respect to y, keep x constant. So see the first term, x is constant, e power x is also constant. What is derivative of cos y? Minus sin y plus here e power x is constant, derivative of cos y is minus sin y again, minus here e power x constant, y sin y. For these two function you have to apply product rule. So y is the first function, derivative of sin y is cos y plus sin y into derivative of y with respect to y is 1. So simplify this, you will get minus x e power x sin y minus e power x sin y minus e power x y cos y minus e power x sin y. So here also minus e power x sin y, here also minus e power x sin y. So you can write 2 times e power x sin y with a minus sign. So this is the first expression where you get it as dou square u by dou x into dou y. Now similarly you have to find out dou square u by dou y into dou x. So first to find out dou u by dou y, differentiating u with respect to y partially first. So x is a constant, e power x is constant, x is constant, derivative of cos y is minus sin y minus e power x is a constant, y sin y, product rule, y into derivative of sin y is cos y plus sin y into derivative of y is 1. So when you simplify this, you will get minus x e power x sin y minus e power x y cos y minus e power x into sin y. Again, you have to differentiate this expression with respect to x now. So you will get, I'll write here. So it is dou square u by dou y into dou x equal to, you are differentiating this expression partially with respect to x now. So treat y as a constant. So sin minus sin y, it is a constant, minus sin y, x e power x, you have to apply product rule. X into derivative of e power x is e power x, plus e power x and derivative of x is 1. uv whole dash is uv dash plus vu dash, minus y is taken as constant, so y cos y is constant, derivative of e power x is e power x, and here y is constant, sin y is a constant, derivative of e power x is e power x. So simplify this, you have to check whether these two expressions same. So that is minus x sin y into e power x minus e power x sin y minus e power x y cos y minus e power x into sin y. E power x sin y, e power x sin y, two times it is. So I'll write minus 2 e power x sin y. Now this is the second equation. Compare these two. You have e power x y cos y term with a minus sign. This is also there and this is also there. So both are equal. Hence you can conclude dou square u by dou x into dou y equal to dou square u by dou y into dou x. So this is how we find the partial derivatives of given function. I hope you understood the concept. Thank you for watching.